Hello everyone, my name is Bandeep. I'm going to walk you through the course project. The What we had to predict in this course was to predict the electrical energy output of a combined cycle power plant. We were given a set of ambient variables in the form of temperature, ambient pressure, relative humidity, and exhaust vacuum, and we were required to predict the net hourly electrical energy output, which is a continuous variable, and we were provided labeled data. So this basically becomes supervised machine learning problem. And since this is a continuous variable, we can use linear regression, right? I have used Excel to work on this project, and I will walk you through the steps which I did, right? So if you look at this particular Excel sheet, this is the one which I used, and used linear regression in Excel to come up with the output. Now, all the four different ambient variables, they are listed here, and also the output variable, which is the net hourly electrical energy output, right? Now, I divided the data into three sets: training, validation, and test. I basically took the 80-20 rule for dividing training data into training and test, and then 70-30 to between training and validation, right? And created three sets of data. I ran linear regression on this data, and I provide input variables as temperature, relative humidity, exhaust, vacuum, and ambient pressure, while the output variable, or the Y variable, as the net hourly electrical energy output, and came up with uh, the the metric for the regression, right? As you see here, this particular is tab talks about what is the output for this. I got a if you see, I've got a fairly high R square as 0.9268 on the training data, and I also got all the coefficients for the four ambient variables and the intercept. Right now, the next what I did is I took the validation data from here, and I created five different sets of I mean, I use the same data, but create five different sets using a combination of features, which you see here, the model A, which is basically the same linear regression model, but it uses all the four features, and also basically the data is of 2,296 rows. Now I use the same equation which I got from a training data set and applied it here to come up with the predicted PE. If you see, the formula is right here, using the same coefficients, and for the random, for the ambient variables and the intercept, right? And I then got the residual from the original output versus predicted, and you see we got a fairly good metric. R square is 0.93, RMSE 0.4, and MAE of 3.5, right? Now, I also did a few experiments and took a combination of features, where in the second one, for example, I've taken a combination of temperature and relative humidity. And if you see, and I did the exact same steps to come up with the metric here. And if you see, the R square here is 0.92, while the RMS is 4.63 and MA is 3.72. This is also fairly aligned with the output of the training data. So, but only thing is, it is slightly inferior than the combination of all the four features that I took. I did the same experiment for the next bunch of ambient variables, which are features here, and came up with a summary of my findings. If you see here, the model A, model to model E, the features used for each of these models and the respective metrics are shown here. And if you review this metrics, you will find that model A seems to be doing well, which uses all the four features, right? With a R square of 0.934. Now, once I have determined that this is the best model, I use the coefficients and intercept from this model to run it on the test data, right? So if you see here, I have got the test data here, which is basically on 1,914 rows of test data, and applied the same formula, which is the same equation which we had applied on the validation data, using all four features, and then got the predicted PE values, right? And similar to what we did last time, I calculated all the metrics, and the R square is 0.92, which is again fairly very high. So it looks like this model is doing well on this data, and it is able to predict fairly close, values closer to the actual output. So the this model should run well on any test data going forward. That's my findings. Thank you so much. Have a good day.